All right, let's pull back the curtain on one of the most important inventions you've probably never ever thought about. The transformer. Seriously, it's this silent, unsung hero that makes our entire electrical world possible, and today we're gonna see exactly how it works.
I mean, have you ever really thought about it? Power is made at some plant, maybe hundreds of miles away, but somehow it travels all that way just to end up in the outlet right next to your bed. How in the world does it make that incredible journey without just, fizzling out? That's the exact puzzle we're going to solve.
So, to make this super simple, let's use an analogy. Just imagine electricity is like water, and the force or the pressure pushing that water, that's like the height of a giant water slide. The higher the slide, the bigger the push, the faster you go. Simple enough, right? Okay, so in the world of electricity, that pushing power has a name. It's called voltage. High voltage is like a crazy tall, super fast water slide. It gives the electricity a massive push. And low voltage, that's more like a little slide at the playground, a much gentler push. And believe me, understanding that difference is the key to everything. Now, here is the big problem engineers had to figure out. Just like a runner gets tired during a marathon, electricity loses energy as it travels through wires. It's called resistance, and if you try to send it with low pushing power, low voltage, a huge amount of that energy just gets wasted as heat. The wires would get super hot, and almost no power would actually make it to the other end.
So the solution seems kind of obvious, right? Just use high voltage. And that's exactly what we do. By giving the electricity this enormous push, it can travel hundreds of miles way more efficiently, with a lot less energy getting wasted. Problem solved. Well, not quite. Because here's the catch. While that super high voltage is fantastic for long-distance travel, it would be an absolute disaster in your house. If you plugged your phone charger into a high-voltage line, it wouldn't just charge it faster, it would instantly fry it. Poof! Gone! It's just way too much power, too much push for our everyday electronics to handle.
And this is where our hero steps in, the transformer. It's this incredibly elegant device that solves both problems at once. It can step up the voltage to crazy high levels for efficient travel, and then step down the voltage to a safe, usable level for our homes. And the most amazing part? It does all this with zero moving parts. It's just science.
So how does this so-called magic work? Well, it all comes down to three basic parts. You've got a primary coil of wire where the electricity comes in, a secondary coil where it goes out, and this big iron core that connects them. The core acts like a magnetic highway, letting the energy jump from the first coil to the second without them ever physically touching.
So what's the secret sauce here? The real trick to how a transformer changes voltage is something called the turns ratio. It's literally just a comparison of how many times the wire is looped around the core on the first coil versus the second coil.
And the rule is it's beautifully simple. If you want to step the voltage up, the second coil needs more turns or loops than the first one. And if you want to step the voltage down, you guessed it, the second coil gets fewer turns. It really is that elegant. More turns, more voltage. Fewer turns, less voltage.
Okay, so with that rule in our back pocket, let's actually follow the electricity on its complete journey. We're going to see where these transformers are hiding in plain sight, starting at the power plant and going all the way to your wall socket.
So, the journey begins at the power plant, and right away, these giant step-up transformers get to work. They take the electricity and crank the voltage way up. We're talking as high as 400,000 volts. This is that massive push it needs to travel super efficiently across the country through those big transmission lines. Then, once that high-voltage electricity reaches the edge of a town, it goes into a substation. You've probably seen them, the big fenced-in areas with all the buzzing equipment. Inside, large step-down transformers start bringing the voltage down to a more manageable level, something like 33,000 volts, to be sent out to local neighborhoods. And for the final step of this whole trip, there's one more transformer, and this one is right in your neighborhood. It could be that gray can on a utility pole, or maybe a green metal box on the sidewalk. This little guy does the last, crucial step down, bringing the voltage all the way down to the safe 240 volts that actually enters your home.
Now, there is one super important piece of the puzzle we haven't mentioned yet. This entire system, the whole shebang, it only works because of alternating current, or AC. Remember that magnetic highway we talked about? Well, it only works if the magnetic field is constantly changing, constantly pulsing. AC does that naturally. It switches direction back and forth. Direct current, or DC, just flows in one steady line, which creates a static magnetic field that can't pass the energy. This is the real reason our entire power grid is built on AC.
So let's zoom out. Why does any of this matter? It matters because we have two totally conflicting needs. We need ridiculously high voltage to move power across long distances without wasting it all. But we also need really low voltage to safely use things in our homes. The transformer, it's the brilliant, simple bridge that makes both of those things possible.
Let me put it another way. Without this device, our modern way of life would be completely impossible. If we tried to send low-voltage power over long distances, the lines would literally overheat and waste a ton of energy. And if high-voltage power came straight into our homes, our devices would be toast, instantly. Transformers prevent both of those disasters every single second of every day. So the next time you flip a light switch or plug in your phone, just take a second to think about that humble transformer. It's a true invisible hero, working silently behind the scenes. And it really makes you wonder, what other critical pieces of technology are out there, hiding in plain sight, just making our world work?